We are going I am just waiting for the others to join. We are going to discuss some more of the simulation today. So I'll be giving you presentations on the different topics for the simulation. If it will be possible for, if the time would permit us, then we will be discussing some more of the simulation. So we are going to simulations on the, let me just check on how can I, there. Let me just see whether if you can see what I am sharing on my screen. Can you see what I'm sharing on my screen?
Yes po, ma'am.
Okay, so this is partly a simulation. So this is all about forces. Later on, we are going to talk about other topics. I hope you've got a glimpse or viewed the posted video tutorial in my YT channel. So that is just a supplementary learning material. So what we are going to have here is a simulation for balancing act. So remember that for the balancing act, it is very essential for any engineering structure, and most particularly being given in the design subject or design courses of civil engineering program. Simply because in the when we talk about designing, our ultimate aim, or our ultimate goal is for us to have a balanced design. So when we talk of balanced design, we have to consider several things. So say for example, in the design for any engineering structure, it would be best that you design the structure relative to different factors like finances, budgetary requirements, structural safety, and also the aesthetic aspect. But in the case of, let's focus on the micro level first. So let us go to the lowest level of designing for balancing. So what we want in any engineering structure is that we design it in a balanced way. So that means we have to make sure that the structure is in balanced condition in order to maintain equilibrium condition, and not for the structure not to collapse. So we are given here a simulation. So you would notice here that we have here a certain, let's say for example, this is a fulcrum. From the fulcrum, you would notice that there is only one support, which is in the middle. So what we want is, if we put or we place or we apply the force in both ends or any portion along the fulcrum, then there would be, say for example, you place here 5 kilogram, you would notice that this one, you would notice that this portion moved upward. So let's say we put another 5 kilonewton on the other side, on the opposite side, you would notice that the fulcrum balanced. So that is what we talk about balancing act. However, if there is an unbalanced force and there is an additional load, say for example, you would want to place this in any portion, that would create unbalanced condition, and you would notice that this portion of the 5 kilogram on the right side of the fulcrum moved up. So let's say what would happen if we place the 10 kilogram on this side. So it's also moved up. But If we place this 10 kilogram on the other side, then the opposite side would go up. So if we remove the 10 kilogram, this would happen. If we remove that 5 kilogram, this would happen. And if you remove another 5 kilogram, then the fulcrum would be in balance condition. So in any engineering structure, you would encounter supports. Okay. So this is what I am talking about, supports. So you would notice that the supports would maintain equilibrium condition. Say for example, we add the 5 kilogram here, there is no effect on the structure. If you add a 5 kilogram here, there is no effect on the structure simply because we have a support there. So let's say what would happen if we place the 5 kilogram here and we place another 5 kilogram here. So there is no change in the formation of the fulcrum. So this time this is not a fulcrum because you already have supports on both sides. So that is what we want for any engineering structure. So that you would recall, or you would see that, or you would observe that in any engineering structure, there is always supports. So what we want is to maintain equilibrium condition. Okay. So let us try having some laboratory here. So if we we check the mass level, we check the forces from objects, we check the level, we would like to add up. So we would like to know where do we place the rulers and the marks. Okay. So let us make use first of fulcrum with no with support in the middle only. So what would happen if we place 5 kilogram here, in here, at 8? Okay. So that would create an unbalanced force and the other side would tilt. Let's say we place another 5 kilogram here on the other side. So we may be able to balance this out. So you would notice that we have a balanced condition here. You would notice that this one is in a green light. So this one is also in a green light. So that means we have a balanced condition here. So let's say we add up 10 kilogram here. That would create an unbalanced force. If we would like to balance it out, you place another 10 kilogram here. Okay, so that is a balanced condition. So the idea here is sometimes or most often than not, in any engineering structure, this would happen that there are some loads which are applied on the right side, which have different weight or different magnitude on the left side. So let's say we add up here 15 kilogram. So that means this portion will tilt up. So we would like to balance it out. What happens if we place a support? Okay. So if we place a support here, whatever load do we provide in both sides of the fulcrum, it would not have an effect on the balance condition. So it would maintain its equilibrium condition. Let's say we place another 15 kilogram here, another 20 kilogram here. Okay, let's say we add up 80 kilogram people here. This one is another 20 kilogram. So you would notice we will have it will have no effect on the balance condition because of the presence of the support. So what would happen? Let's say we add. Okay. So you would notice that there is an unbalanced condition in the fulcrum. So what what's the principle? In civil engineering structure, you would encounter things like you are going to design a beam. So the beam is, in this particular case, is represented by this line, line segment. So this is the beam, and we would like to have in any engineering, civil engineering structure, we would like to design a structure which would not topple down, which will not tilt, which will have a particular concern regarding design, regarding the balance condition. So in any engineering structure, you would encounter loads, you would encounter forces like the 10 kilogram, 6 kilogram, 30 kilogram, or any other kind of forces which have a magnitude of this. In this particular case, this is in mass. So parang ganito lang yung mangyayari doon sa beam. So you would have the load, and then you are going to design for the beam. Were you able to encounter, are you finished with the engineering mechanics already? May I know if you have?
Not yet, ma'am.
Not yet. Okay. So this is what you will encounter in engineering mechanics. So you will encounter analysis of beams, analysis of several beams given different conditions. So this is what we want here. So you have the support here. This is called a simply supported structure. So there are other types of structure, other types of beam with no support, like for example, the support is only on one side, which is a cantilever beam, or you would have this beam with simple support, so meaning at both ends with a given loadings, different kind of loadings. So this is an introductory on your engineering mechanics, by which you will be able to analyze, well, what is the effect or what is the impact or of the different loads which you would encounter in our everyday living. So particularly if you are going to design building and bridges, by which loads are present. So these loads are represented by the this 60 kilogram, 30 kilogram, and then this bricks that we have here. So later on, when you deal with uh, the deeper understanding of engineering structures, then you would appreciate what do we mean by having this 80 kilogram, 30 kilogram. But for the meantime, we are going to talk about what is the effect of these different loads in our structure. Okay, so let me see. If we add here, okay, let's go back to the fulcrum. Let me see. If we add here this mystery object, okay. Question is, what might be the load of this mystery object? In your analysis, since, okay, let's go back to this condition. So we have this condition, and you would notice that when we add this box on the other side, this happens. In your analysis, how much would be, or what would be the amount of the load or the magnitude of the load in this mystery object? Anyone? You give me your perspective, you give me your insight in your analysis. Anyone?
55 po.
How much?
55 po.
You come up with a 55 kilogram.
Pina-plus-plus ko po itong nasa tabi. Ito pong may babae. Then ito pong pina-plus-plus ko din po itong nasa right side. Tapos minus ko po itong nasa right side din sa left side po.
Okay, so that's how you did it. Um, general condition, what most probably be the value of this? Isang malaki ba itong value or what? So that's how you analyze. Let us try we put this on this particular case. Okay, what happens? There is no change, di ba? Okay, so let us try having one more condition. Okay, let us try natin that all the other objects are, okay, let's try. Let us remove all the other objects that we have placed here. And let us try having a balanced, let's say we have a 20 kilogram here, and we place the mystery object here. What can you suggest? What should be the value of the mystery object? Magnitude
20.
20
20 po, ma'am.
20
20, what's the unit?
Kilograms po.
kilogram.
20 kilograms. So what happens if we place it here? What happens if we place it here in the mark of 7? That is on 1.5. So let us put the ruler para makita natin. So we can have a better view on this. Instead of marks, we use ruler. So you have the 20 kilogram, then that means this is also 20 kilogram condition. So what happens if we place it in here? Based on your analysis, what happens if we place this? Sabi nyo 20 kilogram to. So say 20 kilogram this one. Pero nilagay natin ito. What happens? Ano nakita nyo nangyari?
Parang gumaan po yung 20 kilograms nung nasa kabila.
O parang gumaan kasi tumaas itong portion na to. So, what conclusions can you arrive at? Can you derive? Walang nangyari dito. Kahit ilipat natin ng ilipat dito, walang nangyari. So, hindi nakabalance dito sa kabila. Unlike pag nandun siya sa dulo, the same pa rin yan. So, ibig sabihin 20 kilogram. So, what conclusions can you make? Anyone? So, this is a general, there is no right or wrong answer here. I just would like to get from you your insight. So, what we did was we placed this 1.75 on the this mystery object on the 1.75 meters mark. Anyone?
Try lang po.
Yes.
Yung balance po is yung sa pag-balance po, yung isang object po is yung bigat po ng isang object ay may relationship dun sa distance ng nasa gitna.
What do you mean ng distance ng nasa gitna?
Ito pang nasa gitna po yung parang triangle na yellow.
This
Meron
one?
po siyang,
Okay.
opo,
This has the support of the fulcrum, okay?
may relationship po siya dun sa lapit po ba? May relationship po dyan dun sa object na dun sa bigat po ng object.
Okay, so not may relationship yung bigat ng object at yung distance from the support of the fulcrum. Saan? Saan ang relationship niya?
Doon po sa yung object po at saka po sa distance.
Is that naaapektuhan ba, gumagaan? Kasi kung 20 kilogram ito, nilipat natin ang pwesto, naging 15 kilogram ba yun? Pwede bang babago yun, yung bigat niya?
Hindi hindi po siya nababagong bigat, depende po yun sa distance nung isa pong nasa kabila din po.
Okay, so alin ang nababago? Is the big, alin ang na-change? Alin ang may relationship?
Yung ano po yung distance po at saka po yung object. Pero yung bigat po ng object ay hindi po nababago.
Okay, so yung effect ng bigat ng object doon sa balance condition ang meron, di ba? So pero yung kung ito ay 20 kilogram, itong object natin is 20 kilogram, you will not change the distance will have no effect on the 20 kilogram. Okay? But instead, it will have an effect on the distance will have an effect on the balance condition. Okay? So how about if we place here supports? So what can you analyze? What might be your conclusion?
Kahit
Yes?
Magre-remain lang po na balance yung ano, kasi po may support. 'Di ba po 'pag po naglalaro yung mga bata sa siso, 'pag yung pong paa nila ay nakababa, yun po yung parang support nila para mag-balance po yung siso. Kahit po magkaiba po yung weight nung dalawang bata na naglalaro dun sa siso.
Okay, very good analysis. So kahit lagyan natin yan ng lagyan, ng kahit na anong object yan, pag meron kang supports, kaya kung titingnan ninyo in the point of view of, later on you will be a civil engineer, if you are going to see this on the point of view of a civil engineer, that's the reason why we have to provide supports. So yung support na yun, parang simple lang. Pag meron kang bahay, meron kang isang biga. Ang biga natin na tinatawag, yung parang siso, ano. So this is fulcrum. Pag nilagyan natin yan ng load, kailangan natin lagyan ng support. Kasi yun yung magiging, pagka walang support, ang magiging effect niya, unbalance yung condition natin. So yung beam, kapag nilagyan mo ng load on one side, pagka walang support dito, pag magkakaiba yung load niya on both side, nawawala ng balance. Okay? So let us try this one. Try natin tong game na to. Let me see lang kung mag-work ito sa atin. Okay. So we are going to put the rulers na lang. So try to support. Ayaw mag-work ng game. Sorry. Ayaw niya mag-work. Let's see what would happen. Let us check. That is a wrong answer. Let us try again. So where do you want to put the 10 kilogram?
sa 1.25 po.
Sa 1.25. Okay, so let us check. Okay, so we have a 1 point here. X. We would like to balance it out. Let us try this one. Let us check. That is correct. Okay. How about for this one? You are going to balance this out. Where do we put the 10 kilogram?
Sa 1 po, ma'am.
Sa?
Sa 1 po.
1.
Move this is the 5 kilogram. Where do
Sa,
the 5
sa
kilogram?
1 po, ma'am.
1. Lagay natin sa
1
1.
meter po.
0.5 po.
Tama ba yung pwesto na nilagay ko?
Yes po.
Sige, check natin. Okay.
Sa 0.5 po.
So let us try again.
0.5 po, ma'am.
Okay, you have? So wrong.
Sa
1.25
1.5
po.
A 1.
1.75.
So we cannot move more. We have to show the answer. Only 2 lang pala. Okay, so we have to show the answer.
1.5.
Answer is at 1.5. Sige, so let us analyze this first before we go to the next problem. The 1 kilogram is at 0.75 meter from the fulcrum support dun sa center. While this one is a 5 kilogram and it is at 1.5 distance from the fulcrum. What is?
Yung 5 kilogram po is doble nung 10 kilogram. So yung 0.75 po is kailangan din i-doble naman dun sa distance ng 5 kilogram.
Okay. So very good analysis. You would notice 10 kilogram yung load natin dito. Ito 5 kilogram yung load. So ibig sabihin from kalahati ng 10 kilogram yung 5 kilogram. So dapat yung distance madodoble. Diba? So kung ang distance ng 10 kilogram is 0.75 from the center, dapat kung 5 kilogram yung nandito sa kabilang side natin, yung distance na 0.75 dapat madodoble. Okay? Can you conclude?
Okay.
What can you conclude? Anyone who can make a conclusion? Anybody?
Yung distance po nila ay nakaka-apekto po sa weight.
Yung baguhin mo yung, paki-rephrase mo kasi hindi naaapektuhan ng distance yung weight. Kasi kung 10 kilogram yan, 10 kilogram pa rin yun. You rephrase it. Sige nga, rephrase natin yun. Anyone? Tama naman yung idea na merong effect yung weight at saka yung distance. Pero saan ang effect? Kasi iba
Sa
yung...
pag-balance po ng
Para
ano.
po mag-balance.
Okay, sige. You buuhin natin yung conclusions ninyo.
Para po mag-balance, depende po sa distance. Kahit ano pong weight na meron sila, yung object.
Okay.
Basta po, basta po yung distance po is pwedeng maging weight para mag-balance sila.
Sige. Ganito na lang. If the load is or the weight is directly or inversely proportional to the balance condition. If you would like to achieve a balance condition, is the weight directly or inversely proportional?
Inversely po.
Inversely po.
Kapag ka bumibigat ang load, Anong nangyayari sa balance condition? Pagka mas mabigat yung load natin, say, etong 10 kilogram na to, balance ito Pero what would happen kung ginawa nating 15 kilogram itong 10 kilogram? What might happen? Nakabalance ito balance condition to. Yung hindi natin pinapakalman yung distance kasi alam na natin na ang balance condition nito 1.5 ito, dapat 1.5 meters yung 5 kilogram from this distance. Dapat yung 10 kilogram 0.75 from this distance. What happens kung dinagdagan natin ito? Yung 10 kilogram, sige, gawin na natin na 20 kilogram.
Babagsak.
Balance po.
Unbalance po.
Alin ang babagsak? Itong
Nasa kaliwa po.
Okay, so yung left side. So anong ibig sabihin nun? Dahil in-increase natin yung 10 kilogram na ginawa nating 20 kilogram, what does it mean in terms of the balance condition? Is it proportional or inversely proportional?
Proportional po.
Okay, directly, di ba? Directly proportional. Habang ini-increase natin yon, nababago yung hindi natin na-achieve yung balance condition. Okay? Pwede rin kayong gumawa ng other conclusion other than that, but this is how we do the balancing act. So let's say we go to the next one. Question, what is the mass? What most probably be the mass? Meron 30 kilogram. Saan nyo gustong ilagay yung masa ng value? From 0 to 100. So let us try. Ilang kilos ang gusto nyo? Okay, so let us try 50 Tingnan lang natin. That is incorrect. Let's try again. Kung nandun tayo sa 50, try natin yung smaller one. Ginawa lang natin 20 kilogram. Ayaw pa din. So, we have to have 30 kilogram. Okay? For balance condition. Kasi may 30 kilogram doon kanina. Ibig sabihin, kung 30 kilogram yon at 0.25 meters from the distance of the fulcrum. Okay? What will happen? This is what will happen now. We have a 5 kilogram here on the left side. We have a 10 kilogram here on the left side. Both of which are applied 0.25 meters from the fulcrum support. So what would happen? Is this first condition, this condition, or this third condition?
Third condition po.
Third po.
Ito?
Yes po.
Sige, let us check. Okay, so we have a plus 2 here. Next. Let us try placing this one. Pag wala siya ng 30 kilogram, ano supposedly ang weight nito? What might be the weight? Ayaw ng 30 kilogram pag doon sa 1.5. So, ibig sabihin, hindi 30 kilogram yon. Pero pag nilagay mo siya sa 1.25, hindi pa din. Mabigat pa rin yung 30, hindi pa rin kayang ibalanse nung nandun sa kabilang side. Pero habang lumalapit, yung 30 kilogram, dun sa distance, habang lumalapit siya sa fulcrum, so what is the mass?
60 po.
What
60 po.
15 po.
15 po, ma'am.
15
po.
po.
Excuse me lang saglit lang. Yes, Tomas. Oo, bakit? Ay, yung parang ano, parang
Parang pahiri po ba? Nakapila pa po yung isa po noon ay nagdilintahan yung kasama ko isa na malilibot yan. Nagkakalis po kagabi sa doon sa bypass.
ay, pero,
Mamaya pa po daw matatapos yun pagkatapos ng bigay ng bata.
okay, okay.
Yung bukas na lang po kanto mo sana bukas na lang po yung umaga.
Sige. Kung hindi nyo kakayanin ngayon, bukas na lang.
Pag po naman mamaya po ay matatapos kahit mga alas 20, kami pupunta po dyan kahit mga patangalina.
Okay, sige.
Sige.
Sabihin ko na lang. Okay, sige, sabihin ko na lang.
Okay, salamat po.
Okay, sige. So, ano lang answer natin?
15 po.
15 kilograms.
15 po, ma'am.
16 kilogram?
15.
15.
15.
1. Ito bang answer nyo? 1.5?
Yes po, ma'am.
Yes po.
Sige, let's check. Good. Okay, so next. Okay. So that is a good one. Okay. Let's try on level 2. What will happen?
Balance po, ma'am.
Balance.
Ito ang answer niya, yung nasa gitna.
Yes po, ma'am.
Okay, so let's check. Wait, what? Where do we put the 10 kilogram here?
Sa 1 po, ma'am.
0.25 po.
0.25 po.
Alin ang answer? You agree on the answer? Is it 0.20?
0.25 po.
0.25.
0.25 po, ma'am.
0.25 po.
Yung kanina, yung isa 1 meter. So let's 0.25 is the correct answer. Kalahati, 10 kilogram, mas mag-increase ito. So, ibig sabihin, kailangan mas palapitin natin para mabalance yung condition ng fulcrum. Try natin. 5 kilogram, nag-topple down yung ano. Sa 0.75, let us try placing it. You analyze it first, ha? So 1.75, pa rin. If we place it at 1.5, this 5 kilogram, we place it at 1.5, still, we have no balance condition here. If we place it at 1.25, still no balance condition. If we place it at 0.75, ayaw na niya. Medyo malapit na. Mabalance. But still, it is unbalanced. If we place it at 0.5, ayaw mo. 0.5. We've got a balance condition here. So what is the mass of this object?
10.
10 po.
10 kilogram po.
10 kilograms.
10 kilogram. Bakit walang 10 kilogram dito? Yan, 10 kilogram. Is this your answer?
Yes po, ma'am.
Okay, let's check. Okay, that is correct. What will happen?
Balance po.
Hindi po balance.
Babagsak po sa kaliwa.
Okay, you decide.
Yung first condition.
Babagsak po sa kaliwa.
Second condition,
Babagsak po sa kaliwa.
Ang first po.
first condition ito.
Yes po.
Opo.
First condition.
Okay, let us check. Okay, that's good. Next. If we place this 80 kilogram here, move natin siya. Okay, ayaw pa din. This one, ayaw pa din. Right? Ayaw pa din. Siya mabalanse, ayaw pa din. Okay, ayaw pa din sa 0.75. So what is the mass of the object?
40 po.
30 kilogram po.
40 po.
40,
40 po, ma'am.
40 kilogram.
Yes po.
40 po.
Yan ang answer nyo, 40 kilogram.
Yes, ma'am.
Okay, let's check. We have the correct answer here. Next. Where do we put the 10 kilogram to balance the fulcrum?
1.5 po.
1.5 po.
1.5 po.
1.5 po.
1.5 po.
Ito, dito.
Yes, ma'am.
Okay, let us check. Okay, so that's very good. Excellent. We'll continue to level 3. You balance it out. We have a 15 kilogram here. Where do we put the hollow blocks?
0.25 po, ma'am.
Point 20.
25 po.
Okay, that's very good. Okay, next. If we have here 10 kilogram, this would happen. 1.75, this would happen. At 1.5, okay. Then at 1.25, at 1, hindi pa rin siya makabalanse. Sa 0.75, ayaw pa rin. 0.5, malapit na. Sa 0.25.
5 kilograms.
What's your answer? 5?
Yes po, ma'am.
5 kilogram? Okay, so let us check. Next, what will happen? This is the first, second, or the third condition.
First condition po.
Answer?
Third condition.
Okay, magkaiba yung answer nyo. Isa first condition, yung isa third condition. Okay, let's check. Answer ng isa is first condition. That is a wrong answer. Try this one. The third condition. So that is the correct answer. Anong naging analysis natin dito? Sino yung nag-answer nung third condition? You explain?
Yung ano po kasi ma'am, yung sa 3 kilograms po, yung sa 15 kilograms po, ando po siya sa 0.5 na meters position po. Pero kapag yung 3 kilograms po ay, ay tinimes po natin sa 4, ay 12 kilograms lang po yung lalabas. Kaya kapag, ibig sabihin po, kapag po ginawa natin sa 4, ay kailangan po ay naging 12 kilograms na po, di lamang pa po ng 3 kilograms yung nasa kanan.
Okay, so mas mabigat pa din lalabas yung nandun sa kabilang side kasi mas malapit yung nandito sa kanan kasi mas malapit siya dun sa fulcrum support, di ba? Tama ba? Is that your analysis too?
Yes, ma'am.
Okay, so let's go to the next one. Where do we put this 2 kilogram? This one. Where do we put this one? Saan natin to lalagay?
1.5 po.
1.5 po.
Dito sa 1.5. Let us check. Okay, so that's a very good answer. Next one. What will happen?
Third condition po.
Third condition din po.
Others? Ang answer nyo ito na. Third condition.
Yes po, ma'am.
Okay, let us check. Okay, so that's very good. Next. If we place this 90 kilogram so sa 1.75, hindi pa rin siya mabalanse. Sa 1.5, hindi pa din. 1.25, hindi pa din. So, let's say sa 1, ayaw pa din. 0.75, ayaw pa din. 0.5. What is the value of the mass? What is the mass? $60 kilogram. Any other answer? Someone mentioned 60 kilogram. Any other answer? Yes, other answer.
70, ma'am.
70. Sige, try muna natin tong 60 kilogram. 60 kilogram is correct. So we got 11 out of 12 here. Okay, let's go to level 4. What will happen to this one? Is this the first, second, or the third condition?
Third condition po.
Third? Ito ba?
Opo.
Let's check. Okay, so that's correct. Next, where do we put the 30 kilogram? To balance the condition.
Sa 1.
1 meter? Dito?
Opo.
Okay. So let's check. It's wrong. Try again. Any other answer?
Po.
Sa?
2 po
Po.
or
Opo.
1.75?
Let's check. Incorrect. Let us show the answer. The answer should be at 1.5. Analyze nyo nga ulit. Dalawa na kasi yung load dito, isang 20 tsaka 40 kilograms. So, ibig sabihin, once we add this up, this is 60 kilogram. Okay? While this one is 30 kilogram. So, it would really have a effect. The distance would have an effect. Anyway, in engineering mechanics, you would encounter summation of forces. Okay? So you will take summation of forces. When you take summation of forces, that means you are going to take forces with reference to the support. So later on, you will have this when you go to the deeper understanding of how the balancing act would happen. You would have the summation of forces. You take moment, or you take moment 40 kilogram, you multiply it by the distance. 20 kilogram, you multiply it by the distance. That should be equal to 30 kilogram multiplied by the distance. Okay? So, later on, ma-encounter nyo yung ganong solution. But in the meantime, because we are on the physics, we are on the concept already. Okay? So, that means you have the 30 kilogram here for balance condition. Next, let's try if you can, where do we place? If we place the 40 kilogram here, this would happen. If we place the 1.75 here, this would happen. At 1.5, still unbalanced. At 1.25, still unbalanced. At 1, unbalanced. 0.75, still unbalanced. At 0.5, still unbalanced. And we have here 0.25. So, what might be the mass? What should be?
15.
What?
15.
15 po.
15?
15. 1.5.
1, 5. Is that your answer? 1, 5.
Yes.
Okay, let us check. Okay, so that's very good analysis. Next, what will happen? First, second, or third condition? Anyone? First, second, or third condition? Ano answer nyo?
Third po, ma'am.
Third
Third.
condition po.
Third condition. Sige, check natin. E. Next. Anong kasunod na choice nyo?
First condition po.
First condition.
First condition po.
Let's check. So that should be the first condition. Next. If we place this 15 kilogram here, we'll create an unbalanced force. Another in 1.75 is still unbalanced. At 1.5, okay, so what's the mass of the object, mystery object?
5 po, ma'am.
Your answer? 5? Tama
Yes po.
5 kilogram? Okay, so let's check.
60 po, ma'am.
60 po, ma'am.
60 kilogram. Still incorrect.
45.
Yan.
45 po, ma'am.
Okay, very good. 45 kilos.
45 po.
Okay, 45. Next. Where do we put the 20 kilogram? Where do we put the 30 kilogram? 20 kilogram here. How many meters from the fulcrum? Saan natin ito lalagay? Is this at 2 meters? Saan? Where do you want it to be placed?
1.25. Try lang.
Yan, sa 1.25. Okay na kayo? Natin. Incorrect. Pero you would notice, nag-topple down dito, umangat dito sa left side. So, saan ang posible lang natin na ilagay yung 20 kilogram?
Sa mas malayo.
0.5 po.
So, 1 po.
0.25.
0.5 po.
Mas, di ba
5 po.
natin ay 1.25? So,
1.5.
0.5 po.
dun sa mas
So,
Malapit po.
2 po.
malayo. Sa mas?
Malapit po.
Sa mas malapit o sa mas malayo from the fulcrum?
Mas malapit po. Sa 0.5 po, ma'am.
Saan natin ilagay? Sa point? Ito pa answer nyo, 0.5? Tama ba ito ang answer nyo? 0.5? So let us check. Still incorrect. That should be in
1.
sa 1 po, ma'am.
meter. Okay, should be in 1 meter. 1 meter from the fulcrum. We've got 5 out of 12 on the last level. Okay. So, let me stop my sharing here. And then you've got here another force, right to the force. Let's try. What can you analyze?
Balance po, ma'am, yung force.
Okay.
Both sides.
So, dun sa kanina, ang tinignan natin ay loads. Okay, this time we are talking about forces. So, meaning we are talking about pushing and pulling. If mag-move, okay. So, because the same left and right force, okay, so let's return it. If both in the left and the right force have 150 Newton each pulling, kung itong red, nagpo-pull din siya, and then dun sa left, pull din yung force natin, both at 150 Newton, 150 Newton. Kung gusto nating pumunta sa right, itong ma-move natin, itong card papunta dun sa right, alin ang dadagdagan natin ng force? Is this the right or the left force?
Right po.
Right po, ma'am.
Okay, right. Tingnan natin lagyan natin ng another force here. So this becomes 250 Newton. Let's try. Okay. That would happen. Now, if we want to balance this one, so what should we place in the left force? How many force do we have to provide on the left?
100 Newton.
100 Newton. Okay, so let us try this one. And that means there is no change in the positioning. What if we place this one with 50 Newton? What would happen?
Pupunta po sa left.
So let's try. Okay. What would happen if we add up another 100 Newton here?
Mas bibilis po yung pagpunta sa left.
Okay. Very good. So the speed. So let's say if we place another force here, this time, to the right, what would happen?
Nasa left pa rin po yung movement.
Okay, sa left pa rin ang movement, pero
Babagal po.
mas babagal siya. Mas bumabagal. Okay. What if we place here another load? What would happen?
No motion.
Balance po.
Nakabalance na siya, no? So,
Balance po.
okay. So, walang movement na mangyayari. So, that is how you come up with the net force. Okay? So, you take on the sum of the forces, and then you would have the net force. Okay. So, and let's show the speed. If the applied force is, let's say we have okay. So this is how the motion would be affected. Okay. That is the speed. Given is the speed. So you have an applied force and then you have the speed of 5.8. What happens if we add another 50 kilogram? What most probably the condition if we add loads here? You have the applied force is 53 Newton this time. Kanina 50 Newton. So dito, applied force na niya is 53 Newton and the applied force is going to the left. So pag binawasan ulit natin yan, okay, and then we add this one, the 1 kilogram, 100 kilogram, I mean, the speed becomes 3.2 meters. Na mabawasan natin, di ba? So you would notice the speed decreased. Okay. And that the force, the applied force now this time is 2 Newton and is going to the left. Okay, so negative 2 Newton na. Okay, let's go to the friction. Okay, so pag may motion, what's our conclusion? Force is directly equals to,
Direction.
force is equals to mass times
Acceleration.
Acceleration.
acceleration. And then that kapag ka nag-increase tayo ng mass, ano ang mangyayari sa force?
Tataas din po.
Mag-i-increase. Kapag ka nag-increase tayo ng acceleration or ng speed, ano ang mangyayari sa force? Ano mangyayari sa force? Pag nag-increase tayo ng speed, ano mangyayari dun sa force? Should we decrease or should we increase?
Nag-i-increase din
Bababa
po.
po.
Mag-increase pa rin.
Acceleration. If we increase acceleration, what happens to the force?
Decrease po, ma'am.
Mag-i-increase din po.
Yan, mag-i-increase.
Kasi po directly proportional. Ay, tama. Direct proportional.
Okay, now, what happens to the mass if we increase the acceleration? The same ang force, pero yung acceleration ang variable natin. What happens to the mass if we increase the acceleration? Ano ang kailangang mass natin? The same yung force, the same yung force. We would like to maintain, let's say, we would like to maintain 100 kilonewton force. Yun lang yung kaya natin i-apply. Yung acceleration, in-increase natin. Ano ang mangyayari sa mass na kayang dalahin nung force? O kayang i-resist nung force? Is mass directly or inversely proportional to the acceleration?
Inversely.
Indirectly proportional.
Okay, inversely proportional. So meaning, once we increase the acceleration, the mass should
Decrease po.
be
Decrease po, ma'am.
decreased. That is to maintain the same force requirement. Okay, kung ang requirement natin ang constant ay ang force, at in-increase natin ang acceleration, binilisan natin, ibig sabihin yung mass na kaya niyang ma-resist is magde-decrease. Okay, balik inversely proportional ang acceleration sa mass. Okay. Let's go to friction. What's the basic idea on having friction? Stop siya na to. Now, let's go to friction. What's the basic idea on having friction? Anyone? Kapag ka what's the relationship of friction to force? Anyone? Oh, let's go back first to the basic ng friction. Ano ba yung definition natin ng friction? Bakit nagkakaroon ng friction?
Opposite force po.
Two objects moving opposite direction.
How is friction created?
The higher the mass, the higher the weight po, ma'am.
My question is,
Pag po
created.
Gawa po ng
interact yung dalawang objects.
Yes, come again.
Or pag po nag-i-interact yung dalawang objects, nagkakaroon po ng friction.
Okay. Jane, sige. Okay, Nicole.
Dalawa pong object.
Okay, sige, Nicole. Okay na. How about you, Jamie? You were saying something kanina.
Two bodies in contact po. Kunyari po, sandpaper po tsaka wood. Pag pinagkuskus po yun po, doon po nagagawa yung friction.
Yes. Jamie, you were saying something. If there are two surfaces in contact with one another, friction will be created. So that's the basic of friction. So my question a while ago is, what's the relationship of friction to force? How do you relate friction to force? Anybody?
Ma'am, try lang.
Sige, Janeline.
Ma'am.
Yes, Janeline. Go ahead.
Pag po mataas po yung friction ng isang surface po, mas kailangan po ng force, mas much na force po.
Ma'am, ako po ulit reply.
Okay na si Janeline. You, Jamie. Sige, Jamie. Go ahead.
Pag mas malakas po yung friction, mas malakas po yung force.
Anybody? Any other answer?
Ma'am, try lang po.
Sige, Crystal.
Yung friction po is yung force po na ina-apply po ng isang surface pag nag-contact. Para po siyang opposite force na ina-apply.
Okay, sige. Any other insight? Yes, Dan. Yes, Dan.
Ma'am, I agree po dun sa kanina sa paglaki po ng friction is mas paglaki din po ng force na kailangan i-apply kasi po yung friction is nagkakos ng resistance dun sa paggalaw ng object.
Okay, so very good. So merong mas mataas ang friction between two contacting surfaces, mas malaking force ang kinakailangan para sa movement. Okay? So meron tayong term, we have the term what you call as coefficient of friction. Later on, when you go to higher courses, okay, when you go to engineering mechanics probably, or strength of materials, or mechanics of deformable bodies, you will encounter terminologies like coefficient of friction. There is such thing as coefficient of static and kinetic friction. So there are two types of friction. One can be in the form of static movement, static condition. The other one is in the kinetic condition. So when you say static condition, that means anything which is at rest, kapag they are in contact with one another, they will create a static coefficient. There is a coefficient of static friction. Pero kung dalawang object naman moving past one another and they are creating friction, they are in contact with one another, they are creating friction, meron tayong tinatawag na coefficient of kinetic friction. So anyway, mas deeper understanding ang mabibigyan sa inyo when it comes to mechanics of deformable bodies later on. It's all about projectile. So when you say projectile, that means we have a curve force. So let's say if you have an initial speed of, let's say, 15, and we have air resistance, we have velocity and acceleration. By the way, the velocity and the acceleration, when it comes to projectile, would have its components. Later on, when you go to your engineering mechanics and mechanics of deformable bodies, you would encounter terminologies like components. So when you say components, let's say, let me stop my sharing here first. So I can share with you my whiteboard screen first. This 400 Newton would have its vertical component and also horizontal components. So that is how we discuss or we dealt with the force components. So these forces would have its own vertical and horizontal components. Okay. Let's say, for example, you are given, let's say you have 20 Newton, and that is the force. And the force is applied at a certain angle or at a certain degree. Let's say 3:1, meaning 3 rise, 1 unit run. So this 20 Newton would have its vertical component as well as the horizontal component. So this is the horizontal component and this one is the vertical component. Okay? So that is how we dealt with what do we mean by vertical and horizontal components of the force. So you have a given force, let's say 20 Newton applied at a certain angle, you have the horizontal and the vertical components. Okay? So that is how we talk, that is how, what do we mean by components of the force. So now let me go to, let's try this one. So we've got a pumpkin here. The initial speed, that would happen. That's how the projectile, that's what we mean by projectile. So this projectile, this is the line of the projectile, and this projectile, the force of the projectile would have its horizontal and the vertical component. So this one is the horizontal component, while this one is the vertical component. Okay? So you would have for every location, for every position of the projectile, you will have your horizontal and the vertical component of the force. And you would notice there is an impact. Okay, once the projectile or the object reach the ground, then there is an impact in the ground. So that means we will also have horizontal as well as vertical component of the force, okay, created upon impact of the projectile to the ground motion. Okay, so that's how we that's how we illustrate projectile. Okay. Let's try it in slow motion. That's how it goes in the slow motion. You see the green one. That green one is the horizontal component, and you have the vertical component. That is how projectile works. So you would notice again, let me play this one. Okay. So you would notice the vertical and the horizontal components would have its own direction and location. Okay? Habang bumababa siya, papunta dun sa ground, would have its own vertical and horizontal component. Okay? So that is how we create friction. I mean, in the projectile, if we are talking about projectile. Let's say, what would happen if we increase the speed? So let's say we increase the speed. So what do you notice? Once we increase the speed, what happens? What happens?
Mahaba po yung travel distance.
Okay. So, mas malaki, mas malayo yung naabot nung projectile, di ba? Okay, lagay natin sa 20 meter per second. Okay. So, mas umiksi na ngayon yung kanyang distance. So, from the 15 meter here, which is the target point, mas kung nag-increase tayo ng speed, the 30 meter per second, you would notice na mas malayo dun sa target. Nandito yung target natin na 15 meters. So, if we would like to get a target na 15 meter, saan natin anong gagawin natin dun sa speed? Are we going to increase the speed or not? From the 21 meter per second. Are we going to increase the speed or decrease the speed? Ang tanong
Decrease po.
natin ay yung 15 meter. Anong gagawin natin?
Decrease po.
Okay, so let's say how many ang initial speed na ilalagay natin? If you want. Kasi sabi niyo magdi-decrease tayo. So ano yung kanina? Nag-start tayo ng initial speed na 15 meter per second. And you would notice na naglumampas pa din dun sa target. So anong gagawin natin sa speed? I-decrease natin. So mga anong value? What's the most probable value of the speed na gusto nyong ilagay? Would you try?
10 po.
Sige, try natin yung 10. 10 meters. Malapit na, konti na lang, no? Hindi nga lang bullseye, pero nandun siya sa
12.
lalagay natin sa 12. Sige, try natin yung 12. Konting-konti na lang, pero lumampas ng konti pa rin, no? Wala lang siya dun sa bullseye.
11 po, ma'am.
Sige, try natin
11.
10 na initial speed. There you go. So we got a 3-star there. So yeah, that's how the projectile would work. What's your conclusion? From your observation, what can you conclude?
Sa pagtaas po na initial speed ay sa paghaba po ng distance.
The speed has a relationship with the distance traveled by the projectile. Pero ano ang kanyang relationship? Is it direct directly proportional or inversely proportional?
Directly po.
Direct po.
Direct po.
Okay, directly proportional. Okay. Once we increase the speed, the distance traveled by the projectile would also increase. Okay? Let's go to the vectors. How the vector is let me show first it is slow motion. So we are going to show the components, the velocity vector, the acceleration vector, and the force vectors. Okay, when the one that I have shared a while ago regarding the vectors, ito yung tinatawag nating vectors. Vertical, horizontal. So kung meron kang acceleration, may components yan. Okay? So let us try. With an initial speed of 18 meter per second, let us see what will happen to the projectile. Okay, so you would notice while we are doing the slow motion, ulit natin yan. You would notice there are the vectors. You have f dx, f dy, d sub y, and then you have fg. What happens when you go at the peak? Anong na-notice nyo? Nandun siya sa pinakamataas. What happens? Anong nakita nyo na pagbabago? Okay? Oh, mayroon kayo makikita dito ng pagbabago. Ano nangyayari? Ano nakikita nyo pagbabago? Difference? Anyone? Sige, baguhin natin yung para mas ma-appreciate nyo. Tingnan natin. Baguhin ulit natin yung, ipaliitin naman natin yung initial speed. Gawin natin 60 meters. Tapusin muna natin tong sangka. Okay. Try natin tong very slowly. Okay. So what do you notice? Anyone? What do you notice?
Sa components po, ma'am.
Anong nangyari doon sa components?
Yung nung nasa gitna po yung FDX po ay nag-equal po dun sa FDY. Tas habang bumababa po yung FDX po ay bumababa din.
Dating dun sa peak, okay, sige, tingnan natin. Mas palakihin natin to. Try this one. Hindi na natin makita. Wala na siya dun sa screen. So anyway, okay, let's try 24. Okay. So you would notice, sabi niya kanina, doon sa gitna. It's not necessarily gitna. Pinakamataas, yung peak point. Pagdating doon sa peak point, sabi niya nag-equal yung FDX dun sa FDY. Tapos habang bumababa siya, nagkakaroon na ulit ng FDX. So, ibig sabihin yun yung component, horizontal component. Pagdating dun sa peak point, yung horizontal component actually nawawala na yung horizontal component. Okay? Kasi pag tiningnan ninyo siya sa principle ng tangent, if there is a curve here, tapos meron kang line, okay? Pagdating dun sa point na yon, merong a certain point where this particular line is tangent to the curve. Ibig sabihin, nag-touch na yung curve dun sa line. Okay? Let's try moving this one. Kanina naka 80 degrees yung angle niya. This time, let us try 25 degrees. With the same speed of 23 meter per second, what do you notice? What do you notice? We decrease, what we did was to decrease the angle. Kanina itong nauna is ito, 80 degrees ang angle niyan. This time, ang ginawa natin 25 degrees ang angle. What do you notice?
Sa pagbaba po ng angle ay mas mahaba po yung travel distance in terms po ng x-axis.
Okay. So, relative to the x-axis, so yung kanina projectile na free falling body yon. Ito, this time, this is not a free falling body. You've got to have an initial speed of a certain value, and then you will know the distance. You would notice itong distance na na-travel nito, nung naka 25 degrees niya, mas malaki na o mas malayo na yung nata-travel ng projectile. As compared dun sa 80, di ba? 80, yung 23 meter per second, ito yon, yung 23 meter pa, yung 30 ito yung 23. Mas maiksi yung distance na na-travel niya. Okay? So, how can you conclude? What can you conclude? The angle has a relationship with
Travel distance po.
okay, the distance traveled by the projectile, and it is directly proportional to the travel distance. So meaning as you increase the angle of the projectile, the distance traveled by the projectile will also increase. So let us maintain the same angle, but let us use the angle, the speed that we used a while ago. Gumamit tayo ng 10 meter per second kanina. Let us try what will happen if it is a 25-degree angle. Okay. So dahil binawasan natin yung speed, what happens? What happens now?
Maikli din po yung travel distance.
Mas nabawasan din yung kanyang distance na travel. So if we want to hit this 15 meters target, shall we reduce the 10 meter per second speed, initial speed, or shall we increase?
Increase po.
Increase po, ma'am.
So we're going to increase. So anong gusto nyo ilagay natin na initial speed? Anong gusto nyo ilagay natin as initial speed? No right or wrong answer. We're just simulating this one.
15 po.
15 po.
10 po.
15. Sige, try natin yung 15. Malapit na siya.
17 po.
18.
17 po, ma'am.
17 po.
Try natin na 17. na rin. Pero not quite, pero not the bullseye.
16.
16 po.
Okay, so i-reduce natin para medyo lumapit ng konti. I-reduce natin yung kanyang speed para mas lumapit ng konti. Tingnan natin kung mahihit na natin. Konting-konti na lang. What can you conclude? The initial speed should be, para makuha natin yung bullseye, what's the most probable initial speed that we have? Should be between what? 16?
16 and 17.
Ayan.
16 and 17 po. Ika nga 16.5 po.
Pwede rin 16.5.
10.5 po.
Okay, 16.5. Okay, so pwedeng ganon. Try natin, walang 0.5 dito 16 and 17 lang. So at any rate, if you're going to analyze this one, if you would want to hit the bullseye, the initial speed should be between 16 meter per second and 17 meter per second. Okay? So this is considering air resistance. Let us try, wala siyang drag coefficient. Okay, kasi chinek ko dito yung air resistance Let us try walang air resistance. Ibig sabihin hindi natin kino-consider yung air. Okay? At an initial speed of 16, let's try what would happen. What do you see? Yun yung may blue yung walang air resistance na. At 16 meter per second. What can you conclude?
Mas malayo po yung distance traveled.
Okay, mas malayo yung distance na na-travel. So let's try, decrease natin ito by 10 meter per second. Let's try. Without air resistance, ha? So what do you notice? What do you notice? From 16 meter per second, we reduce the initial speed by 10 to 10 meter per second.
Nag-decrease din po yung distance.
Okay, so nadabawasan din yung distance natin. So again, meron tayong target. The target is at 15 meters. So what most probably be the initial speed should be used? Kanina 16 meter per second, then we reduce it by 10 meter to 10 meter per second. But we want to hit the target 15 meters. Ano yung most probable na range ng initial speed natin? It should be between 10 meter per second up to 16 meter per second. So let us try. Try natin yung 13. And let's see what would happen. Konti na lang. Next, try natin yung 14. Ayun. That's the most ideal speed of the cannonball, 14 meter per second without air resistance. Pero pag meron siyang air resistance, okay, let us maintain the 14 meter per second kasi sabi natin kanina, without air resistance, we can hit the target at 15 meters. But with air resistance, let us say, the same initial speed, what happens now with the air resistance? Given the air resistance, we cannot hit the target at 15 meters. So, ibig sabihin, what can you conclude from here?
Yung air resistance ay pwede maapektuhan yung travel distance.
Okay. So, kahit the same ang initial speed na ibinigay mo, na ginamit mo for the cannonball, kapag ka merong air resistance, maaapektuhan niya in a way na mababawasan niya yung distance na natatravel ng cannonball or ng projectile. Okay? So in other words, yung air resistance, similar siya saan? Sa friction, di ba? Tama, mali?
Tama
Tama.
po.
Okay, so similar ang effect ng air resistance dun sa motion ng projectile sa friction. Yung friction nga lang is in a linear motion. Okay? So ito, air resistance yung kinoconsider na. So let us try another condition. Kasi ang diameter ng ball dito, you'd have the diameter of the ball is 0.8 meter. Ang mass niya, 5 kilogram. So let us try, mas pinaliit natin yung cannonball. Ginawa natin na ang diameter niya, 0.2 meters lang. Okay? Given the same initial speed, kasi ang target natin 15 meters, sabi kanina doon sa 0.8, initially kung 0.8 meters ang diameter ng cannonball, mahihit natin yung target. Pero what if we reduce the diameter of the cannonball? So let us try. If we reduce the diameter of the cannonball, what happens? With a given air resistance, what happens? What happens? Anong nangyari? We still hit the target, di ba? So we reduce the diameter of the cannonball with the same initial speed. The resistance is given, we hit the target. What can you conclude now? Anyone? What can you conclude? May effect
Ay,
diameter or wala?
meron.
Meron o wala?
Meron po.
Okay, so let us try. Sige, tingnan natin kung anong mangyayari. Pinalaki naman natin yung diameter. From 0.8, ginawa nating 1 meter. What happens with a given air resistance?
Nag-decrease po.
Po yung
Nag-decrease yung distance na travel.
Distance travel.
Okay. So, anong gagawin natin para ma-hit natin yung target given the same condition? Ano ang most probable value ng diameter ng cannonball? Alin ang mas gugustuhin nyo? Yung kanina na 0.2 meter or itong 1 meter?
0.2.
point
Point 2 po.
Okay. So, mas maliit, ano? That is given air resistance. Pero kung walang air resistance, ibalik natin. 0.2 meters. Walang air resistance. What happens?
Na-hit po yung target.
Nahit natin.
Na-hit po yung target.
Kanina, nung 0.2 meter yung diameter natin with air resistance, nahit ba natin yung target? Hindi.
Hindi.
Hmm?
Nahit po.
Na-hit po.
Nahit natin kanina, di ba? Given yung air resistance, kahit binawasan mo yung diameter, ginawa nating 0.2 meter, na-hit pa rin natin. So, dito, wala yung air resistance, tapos ang diameter niya natin, ibinalik natin sa 0.2 meter, na-hit pa rin natin yung target. Anong ibig sabihin? What can you conclude? Inalis lang natin yung air resistance. O sige, para mas makapag-conclude kayo. Gawin natin na ang diameter ng ball is 1 meter. The same condition tayo ha, yung lang diameter ng ball ang ginawa natin. Without air resistance. Anong nangyari?
Na-hit pa rin po yung target.
Okay, so what can be your conclusion?
Hindi po nagmamatter yung diameter pag wala pong air resistance.
Very good. So kung hindi natin ito consider yung air resistance, lumaki o lumiit man yung diameter ng cannonball, walang magbabago dun sa kanyang natatravel na distance. Okay? Okay, now, what if ang baguhin natin ay yung mass? So, from 5 kilogram, gawin natin mas magaan. Gawin natin 2 kilogram yung ball. Okay? Given the same diameter naman, yung kanina from an initial of 0.8. What happens?
Na-hit pa rin po yung target.
Okay. So kung yung 0.8, anong ginawa natin? Kailangan nating baguhin yung binago natin yung diameter from the original. Binalik natin sa original na 0.8. Diba? Pero binawasan din natin yung kanyang mass. Mas pinagaan natin. What if the same? 0.8 meters, dahil na-hit natin yung target, let us try lang kung halimbawa, mas pabibigatin natin. Dahil yun ay nanggaling kanina sa ano nga yung original na weight niya? 5, ano? So kung nilagay natin yung sa 10, what can you conclude? What can you conclude?
Kahit na anong mass at diameter po siya, basta wala pong air resistance ay hindi po nagbabago yung position.
Sige, tingnan natin ha, yung kanyang distance na na-travel, kahit baguhin natin yung diameter tsaka yung mass, kaya pa rin niyang ma-hit yung target. The same pa rin yung distance na matatravel niya. Pero kung may air resistance, let us try. That is a 10 kilogram, 0.8 meter diameter na ball. Anong nangyari?
Hindi po na-hit yung target.
Mas okay. Hindi na-hit yung target at ang nangyari, yung distance na travel niya ay mas
Nag-decrease.
okay, nag-decrease. So, ibalik natin ulit. Tingnan natin. Sa 2 kilogram, mas pagaanin natin. Given the air resistance, what happens?
Mas nag-decrease po.
Gumaan, mas binawasan natin yung mass, nag-decrease pa rin ang kanyang distance na na-travel. So, balik natin ito dun sa 0.2 kanina. Mas pinaliit natin yung cannonball with the air resistance, pero 2 kilogram ngayon yung kanyang weight. What happens? With a given air resistance. So, pwede pa rin nating ma-hit yung target. So, alisin natin yung air resistance. Ibalik ulit natin itong condition na to, 0.2 meters, then 2 kilogram. What happens? We can still hit the target. Okay. Balik ulit natin yung air resistance. Lagay natin yung diameter ng ball na 0.1, pero mas magaan yung ball. 2 kilogram. What happens?
Decrease. Distance po.
Nag-decrease.
Mas lumiit din yung kanyang nata-travel na distance. Without the air resistance, what can you conclude?
Na-hit po yung target.
Okay. So generally, kapag kinonsider natin ang air resistance, anong mangyayari? May effect siya sa
Distance travel po.
yung diameter at yung mass naaapektuhan ng
Air resistance.
pala, hindi nakakaapekto sa air resistance. Okay? Hindi natin i-consider ang air resistance, walang effect yung diameter at saka yung mass. Okay? So from here, I will stop. Kindly open your video cam so I can document the attendance. Okay. I'm still waiting for the others to open their video cam. Sige, kung hindi maki-open, okay lang. Those who are able to open their camera, okay.